Hello guys, welcome to the chemistry lesson. In today's chemistry lesson, we will be looking at this one here. Let me just show you what we'll be looking at. We'll be looking at the molar mass. Molar mass. Okay. Molar mass, which is abbreviated as M, capital M here like this. So this is molar mass. Let me just underline it like this. Okay, let's underline it like that. Okay, molar mass. So this is a chemistry lesson and we are talking about molar mass. So let's define what molar mass is first of all. So guys, you must understand that molar mass is the mass, okay, it's the mass of one mole of the substance, okay. So this is molar mass, the mass of one mole of a substance. So what does it mean? It means that molar mass has got units of grams per mole. Okay, let me just say the molar mass has units. Molar mass has units as grams per mole. Okay, like this, which I can put in brackets like this. Let me just put it in brackets like this, gram per mole. So this is the unit for molar mass. Okay, so sorry you cannot see me very well because I'm at an angle when I'm writing on my laptop. Yeah, so molar mass is the mass of one mole of a substance. Then a molar mass has units as grams per mole. What it means is this. Molar mass is the mass that you have when you have one mole. The mass of one mole. In short, I can say, in a short, molar mass is the mass of one mole. Meaning that if I got, e.g., if I have one mole of a substance, okay, I have one mole of a substance, and if I get this one mole of a substance, I put it on a scale, the mass that I'm going to get, it is going to be called molar mass. Okay, so if I have one mole of a substance, okay, and I put that one mole of a substance on a scale, so that I find its mass, comma, let me push this one here, then that mass will be called molar mass. Okay, that's what it is in short. So molar mass is the mass of one mole of a substance, as simple as that. Now if you understand this is good. So what you must know also here, another point that you must know is this, that molar mass molar mass is equal in number to either to relative atomic mass of an element or relative formula mass or relative formula mass of an let me just do this, of an ionic compound, or let me just squeeze this one here, let's hope this one will work well, or molecular compound. Okay, so this is very simple to understand. What I'm saying is molar mass is equal to molar mass is equal in number to relative atomic mass. Okay, this one should have been atomic to relative atomic mass of an element or relative formula mass of an ionic compound or molecular compound. What this one means is this, e.g., if I have one more of, let's say, an atom carbon, if I have one more of an atom carbon, then I'm asked to say what is its molar mass. They say what is its molar mass. Okay, what is its molar mass? So I have one more of carbon atom, but I'm asked to find its molar mass. According to the statement I've put, the molar mass of carbon will be equal to the relative atomic mass of carbon. You see, on the periodic table, carbon is written like C. Here we have 6, here we have 12. This value 12 is known as either atomic mass number, okay, or relative atomic number. Let me just write properly here, or relative atomic number. Okay, so now, since here I already put this statement here to say molar mass is equal in number to relative atomic mass of an element. So this carbon is an element and its relative atomic mass is 12 here, as I've indicated. It means if I have one more of carbon, meaning its molar mass will be equal to this 12 here. Okay, let me just push this one here. Okay. All right, so let me push nicely like that. All right, so since this statement we have put across there, so it will mean that molar mass, it will mean that molar mass of carbon is also equal to 12. Now, molar mass has got a units, which will be grams. You put units gram per mole. Okay, I can also give you another situation here. If I say I have like 1 mole of carbon dioxide. This is carbon dioxide. Then the question says, what is its molar mass? What is its molar mass? So I have 1 mole of carbon dioxide. Then they're asking what is its molar mass. So molar mass will be equal to the relative molecular mass of carbon, because carbon dioxide is a molecule. So carbon dioxide, as we already know, like this, its relative molecular formula is found by totaling out the relative atomic masses of each atom here. So carbon, the relative atomic mass is 12, oxygen is 16, so you can total up the relative atomic mass, which will be 12 plus what? Plus 16 times 2. So that then, which will be like 12 plus 16 times 2, which will be like 32. If you add this, you get 44. So now, according to the statement I gave you, that molar mass is equal to relative atomic mass or relative formula mass or molecular mass. Now, since we know the relative molecular mass of carbon, we can also know molar mass. So molar mass of carbon, then, therefore, we'll say molar mass of carbon dioxide, okay, let me just write it in short like this, of carbon dioxide, like this, of carbon dioxide is equal to the same one here, which will be 44. Now we'll just add grams per mole. Okay, so let's proceed to the next page. Let me just move my page nicely here to align it very, very well. Okay, so let's look at another example here. Let's say I have 1 mole of water molecule like this. Then the question says, what is its molar mass? What is its molar mass? So it will be simple. So what I would do, I'll first find the relative formula mass of water. So water, which is H2O. Hydrogen, its relative atomic mass is 1. Oxygen is 16. So I'll total out. So 1 times 2, which is 1 times 2 for hydrogen. Then plus I'll shift to oxygen. Oxygen is just 1, so it will be just 16. So this one, 1 times 2, it will be 2 plus 16 here. Then the total will be 18. So this is the relative molecular mass of water, meaning that it is equal to the molar mass of water as well. So we'll say, therefore, molar mass of water is equal to 18. Now put grams per mole like that. Now let's change the game here. If we were to change, because remember, molar mass is mass of 1 mole, okay, of a substance. Don't forget the definition. We said, this is the definition, don't forget, of molar mass. Molar mass is mass of 1 mole of a substance. Now, if instead of having mass of 1 mole, then they ask you to say, okay, in this case, we give you 2 moles. If they say, what is the mass of 2 moles of water, which is H2O, the question comes in. This becomes simple. You will say, I know from this situation that if I have 1 mole of water, I'm always getting, like here, 18 grams per mole of water. Okay, this is what we get. In short, this is wrong, like this is wrong. This is now correct. So 1 mole is equal to 18 grams, or this one can also be written like this, 18 grams per mole. What I've written like this situation here and this situation here are just one and the same. Okay, so here it says 1 mole is equal to 18 grams. Here it is 18 grams per mole, are one and the same thing. Okay, now the question we are dealing with here is a different one. It is saying, what is the mass of 2 moles of water? So you see, they are asking for mass. So mass is in grams, so you can just connect a relationship. Okay, they've given you 2 moles, they're saying 2 moles, so you can just put a relationship. You say 2 moles, then what is the mass? This side you put x. You see, because 1 mole 18 grams per mole, then 2 mole, what is the answer? You put cross, then you do like this cross multiplication. You say 1 mole times x, what do you get? Let me just proceed to the next page here and rewrite here. We have 1 mole, okay, which is 18 grams. Then we have 2 moles, which we are saying x. Then I said we cross multiply, so you say 1 mole times x. Okay, so 1 mole times x, you are going to have 1 mole times x, you are going to have 1 more x. Then you say equals, then you multiply 2 moles times 18, you are going to have 36. 2 moles times 18 grams, you are going to have 36 gram, and more like that. This more, it's you are multiplying this 2 times 18, you are going to get 36. Then more times gram, you are going to get gram more, like that. Then after you do that, you want x not more, so you divide by 1 more. Okay, even this side you do the same, you divide by 1 more, so that this one and that one cancels, you remain with the x. Okay, you say equals, then also this more and this more cancels, then 1 into 36, you get 36. Okay, then you remain with the grams. Okay, so you are going to say, therefore, you say, therefore 2 moles of water, okay, is equal to 36 grams. You see the situation, how it is rolling out itself nicely. So this is the situation. Let me just squeeze this thing here a little bit like that. Okay, similarly, let me move to another page. Okay, so in the same way, I can ask you to say, what is, let me just put it properly, not the way it is. I can say, what is the mass of 2.5 moles of calcium sulfate? Okay, you see, this is the situation here. What is the mass of 2.5 moles of calcium sulfate? For you to answer this one, first of all, you need to know molar mass of calcium sulfate. If you have 1 mole of calcium sulfate, what will be the mass? First of all, find the relative formula mass of calcium sulfate. So you say calcium sulfate, which is like this. Its relative formula mass will be calcium. Let me just write it properly. Why am I writing it so wrongly like this? So calcium like this. Then calcium on the periodic table, its relative atomic mass is 40. Then this S is sulfur 32. Then O is for oxygen 16. So you total up to find its relative formula mass. So you say 40, okay, then plus, then this sulfur is alone also 32, plus, then this one is 16, okay, times 4. Then you say equals. So this one, let me just do it quickly using a calculator so that I don't waste much of the time. Okay, which calculator will I use? Let me just use this one here, the scientific one. Okay, so using this scientific one, I want to add this one here. So I'll just say 40, you see, plus, then I have 32 plus, then this one I'll just put it in brackets, this one here, okay, because there's times. So equally here, I'm just going to put it in the brackets. So I'll say plus open brackets, I'll say 16 times 4 there. Then I'll say equals. So I'm getting 136. So here I'll put as 136. So this is the relative formula mass. Now finding the relative formula mass, it means that I have known the mass of 1 mole. If I have 1 mole of calcium sulfate, 1 mole, it will give me the mass of 136 grams, meaning this is the mass for 1 mole. Now I'll move. Now I'm given 2.5 moles. So I'll say, how about if you have given me 2.5 moles, okay, what will be the what? The mass here. I'll put x. Then I'll cross multiply, okay. I'll say 1 mole times x, it will be 1 more x. Then I'll say equals, then I'll say 2.5 times 136. Okay, so let me just rub this. So I'm going to say 2.5 more, okay, times what? Times 136 grams. Okay, you have seen it, So I'll say O equals 1 more x as it is equals, so I'll multiply this. So I'll just pick on my calculator as usual. So I'll just say 2.5 times 136 equals 340. So here I'll write 340. Now I'll put more and I'll put grams. Order doesn't matter. Now what I'm looking for is x, not 1 more. So I'll divide here by 1 more. Equal here, I'll do the same, 1 more. So this 1 more goes with that, okay, so that I remain with x, okay. Then this more and this more will go. You have seen it, Then I'll say 1 into 340, it will be 340. Then here the gram will remain and bring it here. Then I'll say, therefore 2.5 moles of calcium sulfate is equal to 340 grams, like that. So this is the concept here. Okay, this is the concept. Okay, let me try this one here. If you want, if you have this one, remember I said this one more, which I'm writing like 136 grams per mole, can also be written like this, or I said it can be like 136 grams per mole. Okay, so this one I can use it also. If I say, I can put it as a fraction. This one I say 136 grams, then I say over mole, then I say equals, then this side I was given 2.5, so I can put x on top of mass, then I say over 2.5. okay, what more, because here it is 136 gram per mole, here it will be now x per this 2.5 moles. Then I'll cross multiply. You have seen it, I cross multiply. I'll say this times that, it will be actually more x if I want, yeah. Then 136 grams times 2.5, it will give me what I got here, which is 340 then grams then more. Now since I'm looking for x, I'll divide here over more. Okay, then here I'll also divide by more, so that this one goes and this one goes, then this one goes and this one goes. So what I'll remain with now is x here. So I'll remain with x here, I'll remain with 340. So it will be equal to 340 grams. You see, just as we found it out here. So this is how you go with this. Let me just give you another example in case you still have issues with these things. Let me put it in this way. Maybe I have this example which says what is the mass of 4.5 moles of ammonia, which is NH3. So they want the mass, right? So what am I going to do? First of all, I need to know what will be the mass of 1 mole. I need to find the molar mass. So I'll get ammonia, which is NH3. I'll get the relative atomic masses of each. I know nitrogen is 14, hydrogen is 1, so which will be equal to 14 alone, like that, plus then this 1 times 3, like 1 times 3, like that. So it will be like 14 plus 1 times 3, 3. Then I'll add 14 plus 3, which will be 17. So which will mean that 1 mole of nitrogen, ammonia, is equal to it will give you what? 17 grams. You put units. So now you can now put it in this way. It can also be like or it can be 17 grams per mole. You have seen it, eh? Now let's use this one now instead of this one. Let's say you have 17 grams per mole. You put it like this. this line per, you put it like this, then you say more down there, then you say equals, this side you don't know the mass, you say x, then you put over, you put 4.5 more, you see, then you cross multiply, more times this x here, you have more x equals, then 17 times 4.5. So let's just do it direct on the calculator. 17 times 4.5, what are we getting? 76. So 70, so we have 76.5. so we'll put gram here, then we'll put more here. Now since we are looking for x and not more, we'll divide by more. Also here we'll divide by more, so that this more and that goes, and this more and that goes, will remain with x is equal to 76 point, oh sorry, yeah, oh it's okay, yeah, 76.5 grams, like that. So it will mean that therefore, we'll say therefore 2 point, oh sorry, not 2 point, but it is 4.5 moles of ammonia is equal to 76.5 grams. So you see how it is going. Now this which I've shown you can be put in a formula as well. So now we see that there is a relationship. Out of these things that we have done, we can conclude that there is a relationship between more than molar mass and physical mass. So from what we have seen, there is a relationship. There is a relationship, okay, between moles, comma, then mass, or let me put this one here, mass, physical mass, let me bring this one down here. Okay, let me just rub these kind of things here, between physical mass, then and we'll say molar mass. So there is a relationship between moles, physical mass, and the molar mass. Now the relationship is here. This is the formula. N is equal to M over capital double M, like that, where I explain this one, N is number of moles, number of moles in units, more, like that, okay. Then this one, M, is physical mass, in units, grams, like this. Then this double M, capital M, this one is molar mass, in grams per mole as units. Now you might be wondering, what is now physical mass? The physical mass, it is the mass which is not for 1 mole. Remember, 1 mole, if you have 1 mole, the mass you find is equal to the relative atomic mass. 1 mole has mass equal to relative atomic mass. Okay, 1 mole has mass equal to relative atomic mass, or molar, not molar mass, formula mass. Formula mass, or molecular mass. Okay, now that is what mole. So 1 mole will be equivalent to relative atomic mass, or formula mass, or molecular mass. Now, if you are not given molar mass, you are given instead maybe 2 moles. That mass which you are going to find is what we call physical mass. Okay, that is where this physical mass is coming from. You have molar mass for 1 mole, then you have the mass for any other moles other than molar 1 mole, then you have number of moles. So this formula also works in the same way as what we have looked at. So let us do this. Let me give you another example of how to use this one now. Okay, let me just align these. So let's have this example here. So this example says, example number 1, find the mass of 2.4 moles of what is this? Of sodium nitrate. Then this one says, another one says, what is the mass of 3.5 moles of sulfuric acid, like that. Then the other question says, what is the number of moles in 16 grams of let me say carbon dioxide. So these are the 3 questions which we are going to use. Now we are going to use that formula. So let's go to solutions. So solution number 1, first of all, we are using the formula this time around. So we use the formula N is equal to mass over molar mass. So the question says find the mass of 2.4 mole of sodium nitrate. So first of all, we need to know this is the formula, so we need to put out the data. So they are saying find the mass, they want M, so meaning they want us to find the M. Now what else have they given us in the question? They have given this one 2.4, so they have given us number of moles, which is 2.4 moles. Now what else do we need? So we don't have molar mass, but molar mass will find it from here. So molar mass will find it from this, okay, NO3. So this one will be, sodium is always 23, then this one, nitrogen is 14, then oxygen is 16. So total will say 23 plus 14 plus 16 times 3 like this. Then we'll say equals. So let me just pick the calculator at once. So I'll say 23 plus, then I'll say here I will have 14 plus, here I'll say open brackets 16 times 3 there, okay, then I'll close, then I'll have 85. So I'll have 85, okay. So meaning this will be molar mass. So it will mean that molar mass, which we need to put here, will be equal to this one here, 85 grams per mole, if I have not made a mistake. So it will be 85 grams per mole. So now what we are going to do is to substitute now. So you can say number of moles, we have 2.4, so we can put 2.4 moles is equal to mass we don't know, so we'll just put M as it is over, then molar mass will put this one here, 85 grams per mole. Okay, so let me move to the next page, but I'll keep this data here. So let me just align my board nicely. Okay, so now what we have on this side, we had 2.5 moles, then equals, we had the mass M, then we have 85 grams per mole like that. Now what we want is mass, so what we'll do, we'll say over 1, will also make this one as a fraction, then we'll cross multiply. 1 times M, will have M, mass is equal to, then we'll have this side 2.5 times 85 gram per mole, so we'll have 2.5 moles times 85 grams per mole. So okay, mass is equal to so we'll multiply here 2.5 times 85 we'll get 212.5, so it will be 212.5, but this mole and this mole will remain with gram here, so this will be the answer, the mass. You have seen, this will be the mass. Then we can move to the next question. The next question is saying, what is the mass of 3.5 mole of sulfuric acid? So second question, which is question number 2, want to find the mass of, so we are given number of moles there, it is 3.5. Let me see. Oh sorry, here we had 2.4, so here 2.4, not 2.5. So here let's change something here a bit. Here we have 2.4, and then also here we have 2.4 also. Okay, so now let's find the correct answer. 2.4 times 85 which is 204. Okay, so the correct answer here is 204 grams. Good. So here now we now on number 2, which is number of moles, 3.5 moles. Then what they're asking us to find is the mass. So put mass m question mark, because if you check here, they're saying what is the mass of 3.5 moles of sulfuric acid. So now what we'll do, we'll know now that molar mass will be equal to that of sulfuric acid. So put sulfuric acid, which is H2SO4. So we'll see this is 1, this is 32, this is 16. So say 1 times 2, so it will be like 1 times 2 plus 32 plus this one will be 16 times 4. Okay, then what we'll do, we'll say equals, so this will be 2, 1 times 2, 2 plus 32 plus, then we'll say 16. If we say 16 times 4, we'll get 64. Okay, so now if we total out this one, now we total everything. So we can say 2 plus 32 plus 64, which would be 98. So here we are getting 98. So meaning molar mass will just be 98 grams per mole. That will be molar mass. So now we'll bring in the formula. Since we want the mass, we'll bring in the formula which says number of moles is equal to mass over molar mass. Okay, now we'll substitute. Number of moles is 3.5. So here we'll put 3.5 mole is equal to, here where there's m we don't know, we'll put m over, then here where there's molar mass we'll put 98 grams per mole. Then here we'll just say over 1, so that we'll cross multiply this times m. 1 times m, it will be m equals, then we can multiply 3.5 if we want direct. We'll say 3.5 times 98, so it will be 343. So it will be 343. Then there is more here. Okay, then there's gram here, then there's bar here, then there's more here. Now this more and this more will cancel, so m will remain as 343 grams as the mass. Okay, so this is now using the formula. So we go to the last question. What is the number of moles in 16 grams of carbon dioxide? So we need to find the number of moles in 16 grams of carbon dioxide. So let me align this one as well. So we need to find the number of moles in 16 grams of carbon. So this is question number 3. So what we are going to do is, number of moles is what they're asking us to find, question mark. They've given us mass as 16 grams. Then molar mass, we don't know, but we can find because it is carbon dioxide. We know carbon dioxide is like this. This carbon alone is 12, oxygen is 16. We already know carbon dioxide after we total here to give us 44. So molar mass will be 44 grams per mole. So we'll get the formula. Number of moles is equal to mass over molar mass. Then we'll substitute where there's number of moles. We don't know actually number of moles is what we are looking for. We'll just write as it is. Mass, we'll put 16 grams over where there's molar mass is 44. So we'll put 44 grams per mole. So you say per mole like that. Then you say number of moles is equal to, you check that this gram and this gram will go. So you say 16 divided by 44. So let me put like this, 16 divided by 44. I'm getting 0.036. So I'm getting like 0.3636636. So we can go on and on, but we'll round it off at least to 2 decimal points. So say 0.36 like that. Then we'll put more. So this is the number of moles of carbon dioxide. I hope you have gotten some ideas in this lesson. Now let me give you a task. We have come to the end of the lesson. Now it is your task. So task, the more you do tasks, the more you know. If you don't want to do tasks, you never know. So task number 1, find the number of moles in 45 grams of calcium carbonate. Full stop. Then question number 2 says calculate the mass of calcium chloride in 6.4 moles. Then 3, I'll say what is the mass of 0.4 moles of aluminium sulfate. Yeah, so these are the questions which you need to attempt and then submit the work for marking. For those of you that will watch this one on YouTube, if you are interested to join my online lessons, then you can join my online lessons by contacting me on online 77924175. Science online lessons are at 120 kwacha, but I'm also offering online lessons in other subjects. Thank you for watching us for now. Bye and see you in the next lesson.